welcome to Basic Technology class. Today we'll be talking about orthographic drawing. In our normal classes, we have discussed about the methods of solving problems that are related to orthographic drawing. We talk about the first method, first angle orthographic projection, which is the British and the European method of photographic drawing. Then we'll talk about the third angle orthographic projection, which is the American and the Canadian method of photographic drawing. But the question on the board, the question on the board here is talking about the first angle type of orthographic projection. You can see the drawing on the board. And the arrow A indicates the front elevation of the object. And you are asked to draw to full scale the front elevation, the plan view, and the end elevation, which is also referred to as the side elevation. As a reminder, we showed you about the issue of the quadrant. This is the first, just to remind, second quadrant, third, and fourth. And we said that in first angle orthographic projection, that the front elevation is usually placed in the second quadrant, the side elevation is usually placed in the first quadrant, while the plan is usually placed in the third quadrant. Also, if it is third angle orthographic projection, the front elevation, the plan view is placed in the first quadrant, the front elevation is placed in the fourth quadrant, while the side elevation is usually placed in the third quadrant. Now, when you look at this object on the board, this place is not dimensional. This place is actually 12 mm. Okay, now, when you look at the object, see, this side has been given to you as a front elevation. Automatically, this other side now becomes your side elevation or the end elevation. Now, I use this blue marker to indicate projection lines or construction line, while the black ink will indicate the visible outlines of the object that we want to draw. Okay, now, we said that in the class, when you want to view an object, of course, they have already shown you the front elevation, which is this view. Okay, now the side elevation is this view. The plan view is usually the view from the top. The view from the top. Now, when you look at this object from this side, also remember that we said that the front elevation and the side elevation, which is also referred to as the end elevation in this question, are always viewed from the vertical plane, while the plan view is always viewed from the horizontal plane. It's always viewed from the horizontal plane. Now, we want to make a drawing of the front elevation from this diagram that we're seeing on the board. Now, when you view this place, what do you see from the vertical view? Okay, you're going to definitely see this side of the diagram that we want to represent it in our drawing. Okay, what is the dimension? The dimension here is 75 millimeters. Remember that all dimensions are in millimeters. Now, from this point to this point is 40, because from here to here is equal to from here to here is as well equal to from here to this point. Okay, now we want to bring it out now. First of all, I want to draw this line from this point to this point. Remember that this place is representing the first quadrant, this one is representing the second quadrant, this is the third quadrant, while this is the fourth quadrant. And we said that in first angle orthographic projection, that the front elevation is usually placed in the second quadrant. So, what is the dimension here? 75. From this point to this point, that is 75. You measure it out with your ruler. This is 75. Okay, until you get to 75. Okay. Now, we want to measure out from this point. This is what we can see from this point. From here to here is what? 40 millimeter. Measure out your 40 millimeter as well. Okay. This is my 40 millimeter. While this is my 75 millimeter. Okay. I bring it out. 40. These are visible outlines. That is why it is actually visible in the drawing. Now, the next one, what I've done to this one line is from here to this point. This from here to this point is from here to this point. While from this point to this point is from here to this point. I want to bring out this other visible outline from here. That is from this point to this point. That is just what I can see from here. You just bring it out. That is the front elevation. Now the question is this all about the front elevation? The answer is no. Now, if you look at the front elevation from this view, arrow A, you will see that this place has been cut off. And when you view it from the position of arrow A, you will see that this place will be hidden. Because it is hidden, we call it hidden detail. So in orthographic drawing, you have to indicate that there is a hidden detail. And what is the depth from this point to this point is actually 12. Therefore, you have to measure it out. So hidden details is indicated using short dashes. Measure it out. What is that? Let me say this one is my 12 millimeter. Okay. This is my 12 millimeter. This is my 12. Now bring out short dashes. Okay. This is my short dashes. Simple. All right. Now that is that about the front elevation. Now the next one is the plan view of the object. The plan view. When you view it, you know we said that the plan view is always viewed from the horizontal plane. This one is the vertical. While the plan view is this horizontal plane. Okay, now when you are viewing it from the plan view, from the top, you are going to see here this place. This place is vertical plane like this, and this place 1, 2, and 3. And what is the length? That is from here to here, plus from here to here, plus from here to here, which will give you 18 plus 14 plus 18. I think that will give you 50 millimeter. So our dimension now will be, the skeletal part of it will now be 75 by 50 millimeter. They have this in the front elevation and the plan. They have something in common because from here to here is 75. And it's equal to from here to here. It's equal to from here to here. It's equal to from here to here. And it's equal to from this point to this point. So let's project this point out. Okay? I project it out. Okay? I'm using my blue ink to indicate that you can actually use a construction line. Okay, let me use that construction line. Okay, you get that. Now, measure out. This we have already measured out our 75. Okay, now let me remind you, if you want to draw, before you draw this line, make sure that you have measured from this point to this point. That is accurate. 75. It must not be more, it must not be less. So this one is my 75. From here, this point to this point. Okay. From this point to this point, that is 50. I bring down my 50. Okay. Let me take this one. This is 50. That is the skeletal part of the plan. The plan view. Okay. We now bring it out. This is skeletal part. That is here plus here plus here. Remember, this place is not part of it because it is vertical. And there's another one like that in the other side. Now, what is from here to here? 80. That is 18. From this point to this point is 18. You have to bring it out. Let me measure it out. From here, there is my 18. From here to here is 14. Okay? I get that my 14. Okay? Bring it out. Okay? That is it. And finally, we have the other one. That is it. Okay? This place is this place. Here is here. Why this point is this place. Now, the next one. Now, once you have done this one, it becomes very easy for you to draw your end elevation. Okay, project this place out. This place is actually inclined at 45 degrees. Okay, you can measure from here to here is 50. You can mark it off, measure it out here so that it will not be less. Okay, project this place out. From here to here is 50. It's equal to that place. 50. Okay, project it. I project it. Okay, let me use the construction line using my glue. Okay. Then I project this one out. Okay. Then every detail is important to us. Okay. I project this one out. And I project this one out as well. Then I project it. Okay. Then I project this one out. Okay. This place, horizontal plane, okay, this line, I project it out. Every detail is important. Okay. Then I project this one out. You can do it step by step. Okay. Let me just project it out. Now let's do it now. Okay. We have to do very fast. You see, from this point to this point, that is from this point to this point. I bring it out. You see, from this point to this point, that is from this point to this point, I bring it out. Okay? From this point to this point, that is from this point to this point, I bring it out. You see, from this point to this point, I'll be fast now, and from this point to this point, I bring them out. Okay? I bring them out. This and this. Correct. Now, from this point to this point, and from this point to this point, I bring them out as well. Okay? Yes. And this. And finally, from this point to this point, that is from this point to this point. Okay? That is just that about the side elevation. Alright? Now, having done that, the next thing we have to do is to dimension our object. Okay? We have to dimension it. Okay, I can dimension it up here. Okay? Let's dimension it here. I want to do it so that it will be fast. Draw it to this point. From here to here. Good. Then, I dimension from this point, from here to here. From here to here is what? This dimension from here to here, 75. Okay? That is from this point to this point. Then from here to here is what? And here to here to here. Of course, that is it. We have 18, 14, and what? 15. Okay? What is the height from here to here to here to here to here? Of course, you know that from here to here is 40, and this place is 12. Okay? 40 minus 12, that will give you 28. Okay. This place, this line, this dimension from here to here is same as from here to here. From here to here, same as from here to here. So that is just the logic behind this simple question on the board. So practice it and stay blessed. Thank you.